Welcome to The Explainer. Today, we're going to dig into something really foundational, the thinking that goes into a great clinical research study before it even begins. We're looking at the first chapter of Designing Clinical Research, which is all about setting up a specific mindset, a way of looking at a study before you even think about collecting data. So, let me ask you this. Where does a truly great scientific study actually start? You might think it's in the lab, right? Or maybe with the very first patient, or some amazing new piece of tech. But the real answer? Well, it might surprise you. Turns out, the real beginning is all in the planning. The main idea in this chapter is that a study starts way before anyone is recruited or a single thing is measured. It all starts with a blueprint, a really detailed, thoughtful plan that gives the whole project its shape and its strength. All right, let's get into it. The book gives us this awesome way to think about the blueprint. It frames a study like it's a living thing with its own anatomy and its own physiology. And honestly, it's such a powerful way to get your head around how research really works. So, how does that break down? Well, the anatomy is basically what the study is made of. All the concrete parts you'd write down in a plan. Think of it as the what. But the physiology, that's the how. It's all about how those parts work together to actually produce a result that's valid, something that's meaningful and true. And right at the very core of a study's anatomy is the research question. The book really hammers this home. The question is the heart of the entire thing. Every single other decision, who you're going to study, what you're going to measure, how you analyze it, all of it exists just to answer that one single, well-crafted question. And this is what that anatomy looks like in the real world. You've got the research question, the study design, who the participants are. All these pieces come together to form what's called the study protocol. And it's so much more than just paperwork you have to file. It's really the researcher's roadmap for keeping everything organized, focused, and running smoothly. Okay, so if that's the anatomy, what about how it all works? That's where we get to the physiology. And if we're going to talk about a study's physiology or its health, it really all boils down to one word: validity. Basically, how truthful are the conclusions you're drawing? One side of that is what's called internal validity. Think of it this way. Are the results you got believable for the actual people in your study? Did you run things well enough that you can trust what you found, at least for that specific group? That's internal validity. And then you've got the flip side, external validity. This is a totally different beast. It's not just about what happened inside your little study bubble. It's about whether your findings actually mean anything for the real world. Can you take your conclusions and apply them to other people in other places? In other words, can you generalize? And this is where we hit a really common problem, a challenge that every single researcher has to deal with. There's almost always a gap, right? A gap between the huge, ambitious question you wish you could answer and the much smaller, more practical question you can realistically answer with the time and money you have. So for instance, your big idea might be to study all older adults. But in reality, you can probably only get patients from your local clinic. Or maybe you want to know their actual caffeine intake, but all you can do is give them a questionnaire and hope they remember correctly. Every one of these little compromises you make, well, it creates a gap that can really mess with your study's external validity. So all these compromises and gaps, they open the door for another big concept: error. If we're thinking of a study as a living thing, what are the diseases that can make it sick? The chapter talks about two main kinds of error that can really undermine the truthfulness of your findings. First, there's random error. This is just, the luck of the draw. It's statistical noise that can push your results around in any direction. The good news is you can usually dial it down by just getting a bigger sample size. But then there's systematic error, also known as bias. And this one is the real problem. It's a fundamental flaw in your design that consistently skews the results in one direction. And the really scary part? A bigger study won't fix it. At all. Okay, let's make this real. Imagine a researcher wants to see if a new drug can help improve memory for older folks. A really important question, right? Could change a lot of lives. But getting people to join a study is tough. So to make it happen, they decide to just recruit volunteers from local health clubs. People who are already super motivated and take good care of themselves. This is a choice they're making about the study's anatomy, about who they're including. So you see the problem here, right? What's the potential issue with this design? How does this little shortcut affect the study's physiology, its health? Well, that choice introduces a systematic error, a bias. That group of super healthy volunteers, they just aren't representative of your average older person. So even if the drug is a miracle for them, you have no idea if it'll work for anyone else. And that just torpedoes the study's external validity. Okay, so you might be thinking, why are we spending all this time on the blueprint? Why does a whole book on research start with this high-level stuff instead of just jumping into the methods? It's actually pretty simple. Good research design is all about prevention. It's about catching those fatal flaws on paper, in the blueprint stage, before you've wasted a ton of time, a ton of money, and a ton of effort, and worst of all, before you end up with the wrong answer. And the authors have this great quote about this. They say that good scientists distinguish themselves by their alacrity in turning over those ideas that won't work and moving on to better ones. I love that. It means being a great researcher isn't just about coming up with brilliant ideas. It's about being really good at spotting the bad ones and tossing them out early. And all of this really points to maybe the biggest theme in the whole chapter, the art of the trade-off. Look, a truly successful study is born from this really careful balancing act. It's the balance between that perfect, flawless study you dream about and the practical, real-world study you can actually pull off. It's not about cutting corners. It's about making smart, deliberate choices. And that is exactly why this is Chapter 1. You have to get this mindset down, this way of thinking about a study's anatomy, physiology, its validity, its potential for error, before you can really use all the specific tools and methods that the rest of the book is going to teach you. And of course, think of this explainer as a guide to get you started, not a substitute for digging in yourself. When you think about it, the quiet choices made in a study's blueprint, they end up echoing throughout its entire life, really determining what that study can ever hope to become.